Welcome to Faith and Science. I'm Dr. John Ashton. Just a few days ago, I was driving along and the local fire brigade was burning off as part of their hazard reduction program, and the smoke, of course, was drifting across the road. And I breathed the smoke in. You could smell the smoke there. It was quite strong, and it was only for a small section, and I'd driven through. But it reminded me that we breathe constantly while we're alive, and we're taking in all sorts of dust and bacteria that are just floating around, viruses and particulates. Often you'll be driving behind a diesel vehicle, and they'll accelerate or change gears or something, and there'll be a puff of black smoke come out. And of course, in city areas, diesel particulates and particulates from vehicles have been in the airways. And so there's, particularly in cities, there can be industrial pollution from different chemicals, residues that are released into the atmosphere and so forth. And not only that, there's dust. I've been, driving in desert areas where there's been a lot of dust, and often dust just from the vehicle in front. On gravel roads and on outback roads. And inevitably we might try to keep this dust out of our vehicles by, putting the air conditioning on with the fan going to generate a positive pressure inside the vehicle. But inevitably we do breathe in the dust. And it's amazing how when you think over a lifetime, our lungs don't, fill up. Obviously, we do age, but, with all this material, really, it's amazing to me the mechanism that keeps our lungs clean. And one of the things that, again, when we're taught the theory of evolution in our schools, colleges and universities, we hear about fish evolving into amphibians, the change from gill systems to lung-type systems, this sort of thing. And we talk about this, that evolved, there were small mutations. But the amount of chemistry and the amount of design that goes into just something like the lungs and our breathing apparatus. And I've talked about this recently, but one of the fascinating things, again, when we drill down, we've got the basic structure of our lungs, but within our lungs we have this cleaning mechanism that involves these hair-like projections that we called cilia. Now, the structure of these cilia is, again, extremely complex. And so not only do we have this design, this amazing breathing system of our lungs where we, exchange oxygen, it's, captured by hemoglobin circulating in blood, so we get this diffusion between the oxygen in the air that we breathe in. Diffuses through this mechanism into our bloodstream. Once there, it's picked up and carried by hemoglobin, and so we've got all this complex chemistry that underpinned that I talked about recently. But also, again, as I said, we've got these other structures that involve cleaning the lungs, for example. And then when we look at the mechanism for cleaning the lungs, within that mechanism itself is a huge amount of design. And to me, this just points to an amazing creator that's been able to think of all these requirements. If our lungs weren't cleaned, we wouldn't really last very long. We would die, quite quite quickly. And so the evolutionists claim, oh, well, there were mutations produced this, but the complexity of the mutations that would be required to produce these machines that operate these cleaning mechanisms are just so involved and designed. And really their design is, in my view, you've got to use the word awesome to think of the intricacy and the way they work so efficiently and effectively. And in fact, there was a paper published in 2023 in the prestigious journal Nature, and it's, anyone wants to look it up, it's in Nature volume 618, pages 625 to 633. So quite a large article, and of course Nature is probably the top cutting-edge scientific research journal or science research journal in the world. And this is by T. Walton and a number of other authors, and it's called Axonal Structures Reveal the Mechanoregulatory and Disease Mechanisms. And this is about these axonal structures that actually make up these hair-like projections. And so these little hair-like projections beat back and forward, and they actually push mucus along with bacteria and particles that are stuck to the mucus. They actually push them out of our lungs. And so we have this mucus lining, as I mentioned before, over our airways, but it moves. And it's moved by this mechanism of these little hair-like projections that push it out. Now, these little hair-like projections are powered by one of the largest known molecular machines. It's called an axome, spelled AXONEME. And this is so large and complex that its intricate design and inner workings have actually puzzled scientists for a long time. And that's why it's only in 2023 that its structure has been revealed. So, there was a paper published, for example, in the Annual Reviews of Physiology back in 2015, on the cilia, and if anyone wants to look up, it was volume 77, pages 379 to 406. Again, a major review article of over 27 pages in length. And as I said, for a long time, scientists have been trying to work out how these machines actually worked. What was their structure? And of course now, and that's why this paper was published in Nature, they've worked this out. And I guess the whole point that I'm trying to get across is there's enormous complexity in these structures, but they're just not random complexity. They function like a machine, where you have all the different parts and the parts are necessary to make the other parts work. They all work synchronistically together. They are part of a machine, and if all the parts are there, the machine isn't going to work properly. And so again, for such complexity to arise by chance mutations and then be assembled. Not only do you have to have the parts, not only do you have to have the molecules, not only do you have to have the chemical molecules as well as the structural molecules, but you've got to assemble them. And the chemicals have to be in the right place at the right time, and their receptors have to be in the right place. The concentrations of the chemicals that produce the changes in the mechanisms and stimulate the different chemical reactions that provide the energy and so forth, all have to be just at the right concentration. They've got to diffuse there at the right rate. They have to be, assembled in the cell at the right time, at the right rate and in the right order, or it isn't going to work. And as our young people are taught that all these things are evolved by natural, simplistic mechanisms, it just blows my mind that this continues to be taught to our young people, that these amazing structures, and as I said, I'm just looking and talking now about the little hairs that are in our respiratory system compared to all the other amazing mechanisms that are in our body and structures and that have similar complexity, and that's just in us humans. And whether you're looking at beetles or a butterfly or a bear or, or a bass fish, they're all got these amazing structures and they're different, but they all work. And they're all programmed by a code which is written in a language, and as I've pointed out many times, this language, just like we talk about an apple as A-double-P-L-E, it's a code. The letters don't look anything like an apple. Or if I was talking in Latvian, wanted to talk about a fish, you use the word zivis, Z-I-V-I-S. Those letters don't look anything like a fish, but they're a code that's got to be translated. The DNA code has to be translated by the ribosome, which then reads the code, assembles the proteins according to the code instructions, and we have these structures formed. And so this continual teaching of this fallacy of evolution really needs to be addressed. And it needs to be addressed as a community effort. It needs people to write into educators and say, look, this is wrong, as we're continually being taught this. It's absolutely impossible. And hence, I put out my book, Evolution Impossible, 12 Reasons Why Evolution Cannot Explain the Origin of Life on Earth. And that's available through, most bookshops, Amazon, Booktopia and so forth. And there's the program on 3ABN television, Evolution Impossible. So if you Google 3abnaustralia.org, go to the television button and scroll down through the programs there. There's Evolution Impossible. Again, many years ago, I wrote to scientists around the world who believed in creation and asked them to explain why they chose to believe in creation. That became the book, In 6 Days, Why 50 Scientists Choose to Believe in Creation. And that's been a strong seller on Amazon now for nearly 25, it came out in 1998, I think. So it's still selling strongly, nearly 25 years later. And so, and again, that's free. The whole book is free now on creation.com. So if you just Googled creation.com, went into their search engine and entered in 6 days, written in words, preface, that page will come up, and down the left side will be a list of names of all these doctorate qualified scientists. And you click on a name and it'll give their reason. And it lists there some of the top scientists in the world in their fields. And so people need to be drawn to the attention that it's absolutely impossible for some blind random mutation mechanism to cause changes in the DNA code to then and these changes in the code actually describe these new structures. It took an international team of researchers, and they used breakthroughs in artificial intelligence, in microscopy, to actually determine the atomic structure of a significant portion of the axonomy. Which is this central tubal structure of the cilia. So it wasn't just one scientist, but it was a team of scientists using the latest scientific techniques to try and understand the structure. It's so complex and large. And it was interesting. I found that it consists of tube-shaped fibres arranged in a highly organised pattern, which are covered. Now, these fibres themselves are covered with a complex array of machines like an ordered factory floor. And these machines actually grab and pull on the neighbouring fibres in response to signals received at precise times to bend the axonomy back and forth in a rhythmic wave-like motion. And it's interesting, the study revealed many other components that use these sophisticated mechanisms to precisely regulate the motion of the axonomy. And the complexity and sophistication of this structure, to me, clearly reveals a brilliant design engineer, and that would be our Creator, Jesus Christ, that the Bible reveals. And again, as I said, those people want to look up and read, in actual fact, the details that were published in Nature earlier in 2023. The volume is 618 pages, 625 to 633. You know, when we look at the human airway and with its, from the trachea down to all the little alveoli, all the little, fine airways that we have that make up our lungs, that cover, about 25 square metres in surface area. And even that structure itself has 4 major cell types, including you've got the cilia cells, you've got secretia cells, and you've got, base cells, and the these basal cells actually make the new cells, their progenitor cells, responding to when the cells die. So the other amazing thing, of course, is that these cilia, are are repaired, are replaced. They're not self-replacing, but they're replaced by these basal cells. And these cilia have all these, as we're talking about, little microtubules and little arms, and they provide motility, which is driven again by this organic compound that provides energy in living cells, adenosine triphosphate, ATP. So again, we've got this complex chemistry that provides the energy to actually move these cells, which is just happening automatically. We don't consciously move that mucus out, but it's constantly moving out, and it's cleansing our airways of these inhaled particles and pathogens that come in there that would otherwise be very harmful. And these ciliated and secretory cells are the first line of defence against inhaled pathogens. There's a number of ways that this happens. There's tight junctions linking the cells that provide a physical barrier. And then there are receptor cells that sense the environment signalling in the cells, and then they go on to secrete defence-related molecules in response to these pathogens and particulates, and also foreign bacteria, antibiotics that have come in. And so, again, we've got this whole mechanism. You've got equipment where we've got receptors, and those receptors send signals. Those signals then secrete molecules that help deal with and respond to these pathogens in the mucus. And, of course, the mucus layer itself helps move them out and helps clean the airways continuously. They're continuously being cleaned. So it's, to me, this is a total system that is set up that is essential to protect us. And when we talk about, lungs evolved and this sort of thing, just this big picture thing, it doesn't really capture the amazing complexity of these structures and the chemistry that is involved in producing the molecules. It's interesting too, of course, that the effectiveness of this, what they call a mucociliary escalator. So again, because what happens is these little cilia and the little mucus layer that's on top of them is continually pushed in one direction. It's sort of like an escalator. And, as an escalator sort of carries on, so the mucus that traps the bacteria, those dust particles, the smoke particles, the diesel particulates, these sort of things, are trapped on this mucus layer. And then as these little hairs move backwards and forwards, they sort of push it up. Each one pushes it over the next one. Then the next one pushes over the next one, the next one. So that layer of mucus is just continually carried as if it's going up an escalator. And that's why scientifically it's referred to as the mucociliary escalator. But it depends on hydration, so making sure that we drink plenty of water, and also the type of mucus that is produced by the secretory cells. And of course, if there is a dysfunction in the way these cilia operate, and remember they've got a bend, and the little motors and machines that bend them. It's an amazing structure. It's very difficult to describe the complexity of this structure without diagrams. It's interesting that the percentage of these ciliated cells increases with airway branching. So in a main trachea, it's about 47% of the surface is covered with these cilia. But when we get down into the very fine areas, about 73% of the small airway is covered with these little hair-like cells. And these are what they call ciliated cells, ciliated cells, have all these little cilia coming out of them. And there's, from 200 to 300 of these little cilia hair-like per cell on the internal surface. And these in the order of 0.2 to 0.3 of a micrometre in diameter and about 6 to 7 micrometres in length. So there's amazing structures there as well. And again, the cilia are divided into different types of cilia that in the structure. Two main types. So there's some that are motile and some immotile. Always we have these cells, of course, not only in our lung airways, but in the whole respiratory system, the sinuses, and also, of course, cilia-type cells are found in many other parts of the body as well. Now, the cilia assembly begins with the formation of the basal transcription factor, which is called 4K box J1 or FOXJ1. And the cilia assembly begins with the formation of the basal body from the centrosome, and which migrates to and docks on the cell surface. And the basal body has a special microtube structure, and a cartwheel is embedded in a pericentralar material and anchored to the plasma membrane by transition fibres. So just, reading about the structure of how this particular structure, cilia structure, forms is, really complex. The microtubule doublets arise from the inner two microtubules at the base body of the microtube of the base or body microtubule triplets and extend from the basal body and form the cilia membrane by pushing out extension of the plasma membrane. And I could go on reading this description in the research paper of how the cells form, and it's extremely complex. One of the things is there's it talks about the transport of proteins that are synthesised in the cells, and they're moved as particular particles by kinesin 2 motors from the basal body to the ciliary tip. And so this is, I guess, another aspect of this, as I'm just reading down through this review paper now, is the assembly of these cilia. They've got to be assembled, and you've got little machines that actually carry the different components and assemble them. It's just amazing in complexity. It would be difficult for me without a diagram and pointing out. And there's a lovely big coloured diagram in this particular paper that was published in the journal, the Annual Reviews of Physiology, in 2015, volume 77, pages 379 to 406. Again, just reading these through the paper now, it's just amazing. The authors go on in one section to say that analysis of the cilia isolated in vitro generated human airway epithelial cells, and they identified over 200 different types of proteins in the axonal. And so we can see the complexity when you look at just the chemistry of the structures that make up these particular components. This complexity clearly, in my mind, points to the Creator described in the Bible. And that's why I think it's so important that we come to know God, our amazing Creator, because He offers us salvation and a hope for eternal life. You've been listening to Faith and Science. And if you want to re-listen to these programs, remember, you can Google 3abnaustralia.org.au and click on the radio button and on the listen button. And remember to tell your friends about these programs too on your social media pages. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.